Alright, in this section here we're going to be solving radical equations. So we have solved some other equations, I think some rational equations and some linear equations in intermediate algebra. And now we're going to be solving radical equations. So of course we try to start with something simple. And we're going to start with the square root of 2x plus 1 is equal to 3. So I'm going to get this out of radical form and put it in exponential form. That would be 2x plus 1. And it's all raised to the half power. Now I'm only going to do this one time. I may do this another time, get it in exponential form. Most of the time I'll just keep it in radical form. Okay, as long as it's just the square root. In other words, this number here is just a 2. Okay, so what I'm going to do here is I'm going to square both sides of this. So we're going to square both sides. And of course, if I square both sides, the idea here is I'm trying to get rid of this radical. And when I square both sides, right, I multiply 2 times a half. And 2 times a half is 1, so we'll just be left with 2x plus 1 is equal to, and of course 3 squared is 9. So that gets rid of our radical. Now I just solve for x, so we basically now just have a linear equation, and we just solve for x in this problem. Bringing the 1 over to the right. So now we're just left with 8, and we have 2x is equal to 8. X is equal to 4. So that's our solution to our equation. Now what we're going to do now is check that. So if I were to plug 4 in right here, this would be 2 times 4 plus 1. Now remember, this is the square root, and it's equal to 3. So we got to hope this side here is equal to 3. So this is 2 times 4 is 8, and 8 plus 1 is 9. And the square root of 9 is 3, and therefore 3 is equal to 3. So that's how you check that. Okay, so this time we have the square root of 5x minus 4, and it's equal to 6. Now you know what, why don't you pause the video and try to work this one out, and then come back and then I'll have it worked out for you if you can't figure it out. Okay, so same thing, 5x minus 4. We're going to square this side, and of course we have to square this side too, so don't forget to square the right hand side. So remember, the square root, right, causes the square root to disappear, and so we're left with 5x minus 4 is equal to 36. And then we have 36 plus 4, bringing that 4 over to the right. So now we have 40, 5x, so x is equal to 8. And of course, you go back up here and you plug 8 in. 8 times 5 is 40. 40 minus 4 is 36, and the square root of 36 is 6. So that'd be the way to check that. Let's see what's going on next here. We have the square root of x squared plus 7 and then minus 4, and that's all equal to 0. Let's solve for x. So I'm going to take the 4 over to the right hand side, and then of course just rewrite. So we have x squared plus 7. Now we square both sides. Right. I'm just going to go ahead and do that right here. Squaring both sides. So remember, when we square a square root just goes away, and so we have x squared plus 7, and we square 4, we get 16. All right. Now we want to take the 7 to the other side, so we have 16 minus 7, and x squared on the left. So this becomes 9, and then we have x squared. So now what we want to do is get rid of this square. We square root both sides. So we're going to now square root both sides. So the square root of a square causes the square to go away, just the opposite. And the square root of 9. Now we need to write plus or minus here. That was something I should have done. Plus or minus, when we square root, we gotta write plus or minus. So this becomes plus or minus 3, right? Square root of 9 is 3, so we have plus or minus 3. Now I think what we need to do now is check this. So I'm going to rewrite. This is x squared plus 7 minus 4. Alright, let's check it. So we plug in the 3 there. Minus 4, and that should equal 0. So 3 squared is 9, and 9 plus 7 is 16. And square root of 16 is 4, and 4 minus 4 is 0. Now let's check the minus 3. So we plug in negative 3. Squared plus 7 minus 4 is equal to 0. So then again, when you square a negative, right, the negative disappears. So negative 3 times negative 3 is a positive 9. And 9 plus 6 is, where are we at here? 9 plus 7, that's 6. Alright, is 16, and so yes, this is all equal to 0. Alright, so that works. Okay. What do we got next here? Of course, as we always move along, they always tend to get a little bit more difficult. That's just the way it is. Okay, so I'm going to take the 1 to the other side. And we're left with x squared plus x minus 5. And to get rid of this square root, we want to square both sides. Alright, so we square both sides. And so now we're left with an x squared plus x minus 5 is equal to 1. Bring the 1 over to the left. We have x squared plus x minus 5 minus 1. And then we have x squared plus x minus 6. And we want to factor this guy. So this should factor to a plus 3 and a minus 2. So our solutions, we set each one of these equal to 0. So x is negative 3, and x minus 2, x is equal to 2. So to check our work, we want to take our solutions here and plug them in to make sure that the left-hand side is all equal to 0. Alright, so you take the negative 3 and you'd plug it in right here. So negative 3 squared is 9. And 9 plus negative 3 is going to be 6. And 6 minus 5 is 1. And the square root of 1 is 1. And 1 minus 1 is 0. And of course our other solution was 2. So let's try that. So 2 squared is 4. 4 plus 2 is 6. And 6 minus 5 is 1. And the square root of 1 is 1. And 1 minus 1 is 0. So it looks like that both of our solutions are working. Okay. So time for a new one. And let's see what I've got up my sleeve here. We're going to have the square root of 4x minus 12 is equal to the square root of 3x plus 2. So in order to get rid of both these radicals here, we're going to square both sides. So I guess I should just rewrite it. 4x minus 12, we're going to square this to get rid of this square root. And then we're going to square this side here. 3x plus 2. And let's square that. So when we square the square root falls out somewhere down into the abyss. I don't know, it disappears to the ether. Okay, so we've got rid of our radicals, and now it's just a matter of solving this linear equation. And so I'm going to bring this 3x over, and when I do, it becomes a minus 3x, and then I'm going to bring this 12 over here, and so we have 2 plus 12. And let's see what happens here. 4x minus 3x is x, and this just becomes 14. So 14 is our solution. So once again, you want to go up here, plug it in the left hand side. I think it comes down to the square root of 44, and then the right hand side comes down to the square root of 44. So we know that 14 is a solution, and it's the only solution actually. When we get into graphing, which is in the next section, after complex numbers and applications, I think the next major section is we're going to get into graphing some functions, I believe. And so you'll be able to put a picture to all this stuff. Okay, let's look at another one. We have 2x, and I do believe it helps out to be able to present a picture with what we're doing, because that's usually how most of us think, is in pictures. Well, to get rid of this radical here, we want to square both sides. Yeah, I don't know about you, but I dream in pictures, not math equations. Of course, I have had lots of math dreams, but most of them are, it's some type of a picture that I see. Okay, so this is where we're at. We want to now, let's say, take everything over to the left. So there we go. And we want to factor this thing. And I'm going to help you out here. This is going to be 2x. I had to do some little trial and error on this problem, but we're not going to do that. Waste of time. This becomes positive 3 and a minus 5. Alright, and of course you set both of these equal to 0 and solve for x. In the section, I think, factoring polynomials or trinomials, this is a polynomial, it's also a trinomial, I go over factoring. So anyway, okay, Now that we've factored this thing, we want to set both of our factors equal to 0. And we're going to do that. So this becomes 2x plus 3. Set that equal to 0. X ends up being negative 3 halves. Then we want to set 2x minus 5. Set that equal to 0. And that becomes x is equal to 5 halves. So the question is, are these solutions? Now there's a reason why not only I've been going back and checking our answers, but it could possibly be that we come up with a possible solution, but it may not work. Take for example negative 3 halves. Okay, if I put a negative 3 halves over here, 2 times negative 3 halves, this is equal to negative 3. Well, you can't get, we take the square root of a number here, our answer cannot be negative. So negative 3 halves is not a solution to this equation. However, 5 halves on the other hand is. Okay. If you plugged in 5 halves over here, the 2's cancel out, you're left with a 5. Plug in 5 halves in here, 2 goes into 4 2 times, and 2 times 5 is 10, and 10 plus 15 is 25, and the square root of 25 is 5, and that's what we had over here, was equal to 5. So as you can see, this is not a solution, but this is. That's our only solution. Right? So that's just kind of a reason why we need to definitely go back and check. Okay, I think I've got one more here that I'm going to work. This one's going to take a while. We got to definitely end it on a difficult one. Alright, let's see. If we have the square root of 2x minus 3 minus the square root of x minus 5, and we're going to set that equal to 2. So the first thing I'm going to do here is I'm going to take this over to this other side. So we have 2x minus 3 is equal to 2 plus the square root of x minus 5. Now remember, to get rid of these radicals we square both sides, so that's what we're going to do. We're going to go ahead and I'll just write it in right here. So we're going to square both sides, so that's going to get rid of the radicals. So we're going to be left with 2x minus 3. And of course, by squaring both sides here, we're going to be multiplying itself. Okay, so we do nothing over here, so 2 times 2 is 4. 2 times the square root of x minus 5 plus, and then 2 times the square root of x minus 5, and then square root of x minus 5 times square root of x minus 5 is just x minus 5. Alright, and of course I'll just rewrite this. And we want to simplify this down, so 4 plus 4 square roots of x minus 5 plus x minus 5. Now I'm going to go ahead and take, let's see, we're going to combine that stuff. 4 minus 5 is, I guess I'll just rewrite, skipping any steps. I'm going to rewrite 2x minus 3. Now what I'm going to do is go ahead and take this x and this minus 1 here over to the left hand side. So we're going to end yeah, just making sure, checking things out here. Alright, so we have 2x minus 3, bring the x over, that becomes a minus x, and then bring this minus 1 over, becomes a positive 1. And so now we're left with 4 times the square root of x minus 5. We want to now simplify this left side, so 2x minus x is x. And negative 3 plus 1 is negative 2. So we got to get rid of this radical here, and we're going to do that by squaring both sides. So I have x minus 2 squared. So we got a little bit of work going on in this problem compared to the others. And square that side. Okay. So we square that, so this is x minus 2 times x minus 2, and I'm going to go ahead and square this. This becomes 16, right? 4 squared 16, and we square square root, that goes away, so we're left with x minus 5. So x times x is x squared, x times negative 2 is negative 2x, and then negative 2 times x is negative 2x, so that makes negative 4x. And negative 2 times negative 2 is a positive 4. I'm going to go ahead and distribute that 16 across, so that's 16x minus what is that minus? Let's see, 16 times 5 is 30, 5, 6, 7, that's 80. Okay. And now taking this stuff over here to the left hand side, so we're going to have x squared minus 4x plus 4. Go ahead and write that, get that out of the way. Minus 16x, and then we got this equal sign in the way. Hopefully you can ignore that. Plus 80, and that's all equal to 0. We want to collect up our like terms, so we have x squared minus, that looks like, what is that, 20? Minus 20x, and plus 84. Now we want to factor this guy, so we know it's going to both start with x's here. And the factors of 84, let's try 6 and 14. And that's a minus, that's plus, so probably minus minus, right? Because 14 minus 6 is negative 20. We set both those equal to 0. And so x is equal to 6, and x minus 14 is equal to 0. So we have x is equal to 14, and these are our two solutions. So we had some work to do on this problem. And if you would like, I've already checked this of course, but if you would like, you could go up here into our original and check that out and make sure that 6 and 14, what we got to really look for is make sure we don't have negatives under here. 14, that's not going to be a negative, and 6 under 14, no, that won't be a negative either. 6, no. So those are going to be both of our two solutions to this, and I think I'm going to end this section on that problem and move on to something bigger and better. I think complex numbers is coming up, and boy, that's a mystery to a lot of people. Okay, have a good one.